It has been 2 years since the James Webb Space Telescope, operated by NASA, gave us a breathtaking first glimpse into the far reaches of our universe. The largest and most powerful space telescope, this $1 billion instrument, known as the James Webb Telescope, captured stunning images that revealed information NASA had been concealing about Mercury. Following this discovery, the United States quickly halted the mission. This seemingly ordinary planet is far from what it seemed, as it orbits close to our massive sun. Surprises abound throughout Mercury's scorching landscape, including sparkling diamonds. But beneath its glittering surface lies an enormous and mysterious core that challenges our previous scientific knowledge. What other enigmatic tidbits of knowledge lie behind these startling revelations? Let's explore the discoveries that might dramatically alter how we understand the planet. Despite Mercury's apparent insignificance in comparison to the Sun, don't be fooled by its size. Beneath its intense, boiling surface lies a wealth of incredible secrets. A shocking discovery was recently uncovered by Earth-based probes. The surface of Mercury is covered in diamonds. These remarkable gems exist on one of the hottest planets in our solar system. But this is just the beginning. As we investigate further, we discover that Mercury's core is bizarre and exceptionally large. These results raise important questions. What sets Mercury apart from its neighboring planets, and what other hidden phenomena might it conceal? The Mariner 10 spacecraft was a pioneer in space exploration because it was the first to reach Mercury. It returned the initial close-up photographs, revealing a planet marked by craters and strange ridges. Much like our moon, this mission shattered long-standing assumptions about Mercury's makeup, showing that it has a rugged surface, an unexpectedly powerful magnetic field, and a core larger than previously imagined. However, this wasn't the most shocking revelation. 3 decades later, the Messenger mission came along and transformed our understanding of Mercury. Unlike Mariner 10, Messenger was designed to orbit Mercury, enabling detailed, long-term observations. It took nearly 200,000 images, revealing previously unknown areas of Mercury and significantly expanding our understanding of the planet. Among Messenger's key findings was the discovery of unusually high concentrations of calcium and magnesium on Mercury's darker side. This sparked interest in the natural processes that might be responsible for the elevated levels of these elements. In addition, the discovery that Mercury's northern hemisphere had a magnetic field surprisingly stronger than that of other planets in the solar system surprised scientists. Scientists were forced to reconsider their previous assumptions regarding Mercury's interior and its geological evolution as a result of these findings. On Earth, the movement of molten iron within the core is primarily responsible for generating magnetic fields. However, Mercury exhibits a unique kind of magnetic activity due to its distinct internal structure. But what else sets Mercury apart, aside from its craters and ridges? The planet's surface experiences extreme weather. During the day, temperatures can soar to a scorching 800 degrees, hot enough to melt lead. Yet, at night, the temperature plummets to around 290 degrees. Mercury's thin atmosphere does little to retain heat or regulate temperature, resulting in dramatic temperature shifts. But there's more to Mercury than just its extreme heat. Recent investigations have uncovered some surprising features. In 2012, the Messenger mission's data revealed signs of ongoing volcanic activity and evidence of ancient explosive eruptions. This challenged the earlier theory that Mercury had been geologically inactive for billions of years. Then, in 2020, scientists made another fascinating discovery. Portions of Mercury's permanently shadowed polar craters contain water ice. Despite Mercury's proximity to the Sun, these regions remain cold enough to preserve frozen water because they are shielded from sunlight. This discovery raised new questions about whether Mercury could support primitive life forms in these frozen regions, much like Earth's most inhospitable environments. This question has interesting repercussions for our comprehension of the possibility of life surviving on other planets, particularly in hostile environments. But the story doesn't stop there. The Bepi-Colombo spacecraft, launched toward Mercury in 2018 by the European Space Agency in conjunction with the Japan Aerospace Exploration Agency, is expected to reach the planet by 2025. Once there, Bepi-Colombo will start gathering extensive data about Mercury, including its surface composition and geological history. Interestingly, despite being so close to the Sun, Mercury has both water ice and a strong magnetic field. What might surprise you even more is that a day on Mercury is actually longer than its year. When we think of a planet, we typically imagine it orbiting the Sun once every year and rotating on its axis once per day. However, Mercury defies this expectation. A day on Mercury, or a full rotation on its axis, takes around 176 Earth days, while its orbit around the Sun takes only 88 Earth days. This means a year on Mercury lasts only half as long as a day. This results in some very peculiar phenomena. As seen from Mercury, the Sun rises and gradually grows larger across the sky. But then something strange happens. The Sun appears to pause, reverse its path, and then continue on its journey. This is because Mercury rotates slowly compared to how quickly it moves around the Sun. But why does Mercury rotate so slowly? The answer lies in tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed down Mercury's rotation. Mercury is in a 3.2 spin orbit resonance, which means that it completes 3 rotations on its axis for every 2 orbits around the Sun. This creates a unique daylight cycle that contributes to extreme temperature variations on the planet. Temperatures can reach scorching highs on the side that faces the Sun, while long stretches of icy darkness continue on the opposite side. These temperature swings are among the most extreme in our solar system. It's important to note that Mercury doesn't have a traditional atmosphere like Earth. Instead, it has a very thin exosphere, which is so sparse that it continuously evaporates into space, replenished only occasionally by solar wind, radiation, and collisions with small space debris. Recent research has revealed some unexpected details about Mercury's exosphere. Data from the Messenger spacecraft in 2020 showed that scientists had previously underestimated the amount of water vapor in Mercury's exosphere. This water vapor likely forms when oxygen from Mercury's rocks interacts with hydrogen from the solar wind. Another astonishing feature of Mercury is the speed at which it orbits the Sun, especially when compared to its slow rotation on its axis. This strange combination has a significant impact on the planet's magnetic characteristics. Scientists were astounded to discover that Mercury has a strong magnetic field despite its relatively small size and sluggish rotation. According to subsequent research, the planet's magnetic field is influenced by the planet's unique spin and orbit, as well as the peculiar movements that occur within its liquid metallic core. Nevertheless, it is essential to keep in mind that Mercury's magnetic field is significantly weaker than Earth's. Mercury's surface is protected from the harsh solar wind by its magnetic field. Without this shield, the solar wind would further thin the already sparse exosphere. Mercury's slow spin and rapid orbit create fascinating conditions on the planet's surface. For example, Mercury has hot poles where the Sun appears to hover for an extended period of time, causing extreme heat. On the other hand, areas near Mercury's poles remain perpetually dark, keeping them cold enough for ice to survive despite the planet's closeness to the Sun. Mercury's slow rotation and rapid orbit present challenges for space exploration. In order for a spacecraft to slow down enough to enter Mercury's orbit, it must use complex navigational strategies, including multiple flybys of Venus and Mercury itself. These flybys are currently being used by the 2018 launched Bepi-Colombo mission to adjust its speed and trajectory. Once it arrives in 2025, Bepi-Colombo will need to carefully manage its power and temperature systems to survive Mercury's peculiar daylight cycle. New insights into Mercury's evolution and planet formation continue to astonish scientists. Research suggests that Mercury may have originally spun more rapidly before gradually slowing down due to the Sun's gravitational pull and possible impacts from other celestial bodies. This discovery provides more insight into the history of Mercury and the forces that shape planetary evolution. As scientists continue to explore, new questions arise about Mercury's core, surface, and the unique forces that have shaped it. The more we learn, the more we realize how much Mercury challenges our understanding of planetary science. Mercury remains the smallest planet in our solar system. However, it still retains a lot of mystery for scientists. One of the most remarkable features of Mercury is its gigantic core. According to planetary scientist Dr. Nancy Chabot, Mercury's core makes up about 85% of the planet's total volume, while Earth's core accounts for just 15% of its total mass. This raises an important question. Why is Mercury's core so enormous? One popular theory suggests that Mercury was once much larger, but lost much of its outer layers due to a massive collision early in the history of the solar system. This theory, known as the giant impact hypothesis, proposes that a giant object collided with Mercury, stripping away its outer layers and leaving behind the dense, iron-rich core that we observe today. Mercury's magnetic field, though weak, is also a source of fascination. Despite its small size and slow rotation, scientists were surprised to find that the planet has a global magnetic field, unlike Venus and Mars. This discovery, made by NASA's Messenger spacecraft, led to further investigations. Researchers also discovered that Mercury's magnetic field is uneven. Dr. Katherine Johnson and her team found that Mercury's radius is displaced by about 20%, which may be linked to variations in the planet's crust and the way heat is released from its core. Further research in 2020 revealed that Mercury's surface contains volatile substances like sodium, potassium, and sulfur. These findings added to the growing body of knowledge about Mercury, making it one of the most intriguing planets in our solar system. As we continue to explore, Mercury's mysteries continue to unfold, challenging our understanding of planetary formation and evolution. As scientists investigate Mercury's numerous enigmas, they continue to be captivated by its mysteries. While some discoveries offer glimpses into what the planet may hold, many questions remain unanswered. One of the most intriguing aspects of Mercury is the presence of compounds that, at such high temperatures, would typically vaporize. Dr. Patrick Peplowski of the Johns Hopkins Applied Physics Laboratory proposes the possibility that these materials were delivered by comets or asteroids much later in Mercury's formation. One of the most exciting revelations about Mercury is the existence of water ice in the permanently shadowed craters at the planet's poles, a discovery made possible by the efforts of Dr. Nancy Chabot. These craters are so cold that the ice remains frozen, and the possibility of complex carbon molecules, similar to those that may have sparked life on Earth, being present there adds another layer of intrigue. Could Mercury, with its extreme conditions, offer clues to the origins of life in our solar system? When it comes to Mercury's geology, there have been more surprises. Once thought to be geologically inactive for billions of years, new data from NASA's Messenger spacecraft points to recent volcanic activity. Dr. David Rather from the Open University in the UK uncovered tiny, shiny volcanic vents, known as hollows, which offer insights into the planet's ongoing geological processes. Mercury's surface features include hollows, which suggest that the planet's geology may still be developing. Another peculiar aspect of Mercury is its chaotic terrain, a vast, disordered region near the southern pole, first identified during the 1970s Mariner 10 mission. According to Dr. Thomas Waters of the Smithsonian Institution, this region may have been shaped by massive, Earth-like earthquakes brought on by the Sun's gravitational pull. Mercury's internal structure is just as fascinating. Using data from the Messenger mission, Dr. Amir Khan of the University of Zurich revealed that Mercury has a large, solid inner core surrounded by a liquid outer core, much like Earth. However, Mercury's inner core is much larger, which could explain its unique magnetic properties. This unexpected information challenges our understanding of planetary formation and evolution, showing that there are still many secrets hidden in the solar system. Additionally, the MESSENGER mission revealed that Mercury's mantle is only 260 to 420 kilometers thick, compared to Earth's much thicker mantle. This thin mantle influences the planet's heat distribution and geological activity. Researchers found evidence of ancient volcanic activity beneath Mercury's surface, including shallow depressions called hollows that formed when volatile compounds near the surface evaporated. In 2020, scientists found signs of a large magma reservoir that once lay beneath Mercury's surface, shaping large, flat plains, particularly in the northern hemisphere. These volcanic plains, known as the Northern Volcanic Plains, were likely formed by massive lava flows early in Mercury's history. In 2022, further investigation of the MESSENGER data unearthed additional mysteries, including indications of nitrogen trapped below the surface. This suggests that Mercury may have once had a denser atmosphere that was driven underground by the planet's extreme heat and relentless solar radiation. Another fascinating discovery involves the ice found in the permanently shadowed craters at Mercury's poles. Despite the planet's close proximity to the Sun, this ice is shielded from the Sun and remains frozen. Some of this ice could be relatively young, likely delivered by comets or asteroids over the past tens of millions of years. The possibility of organic compounds being present in these frozen regions raises more intriguing questions about the potential for life or its precursors to have existed on the planet.